I don't know if you've ever seen anything like this before, but I wanted to make sure we at least go over number one if we don't do anything else, because it is such an important thing. We think, again, that's what SAT questions might look like. When you get problems like this, you're trying to figure out, all right, they showed me, this is like in stages. In the first stage, we have 1 dot. In the second stage, we have 3 dots. And you kind of notice how they're arranging them. Aren't they adding a row and adding another dot each time they add a row to this on your worksheet, your warm-up worksheet? Isn't that what it looks like is happening? They add another row, and when you add the row, you're actually adding an additional dot to what was in the row above it. Okay? Now, I don't know about y'all, but I look at these equations and I think, I don't know what I'm supposed to do here. Here's how you can break this apart. There are a lot of problems they can write like this, and this is kind of a format they like to write problems in. And what it is, it's a function in disguise. And here's what you're going to do with it. If you take and you make these things into points, like coordinate points, like that have an x, that you're going to plug into an equation, and a y you're going to get out, this will help you figure this out. So let's kind of go through this process so you could see what to do if you ever saw something like this show up on your SAT. When you see these n equal 1, n equal 2, n equal 3, n equal 4, those are going to be like my x's. And I'm going to go ahead and call them x's, because in a minute I'm going to use my calculator to help me figure out which one's the right one, instead of me, beating my head in the desk if I feel like I can't figure it out. So I would say x is 1. My n's and my x's are the same thing here, okay? So how many dots do I have? So in my coordinate point, this is going to be the stage that I'm in, 1, 2, 3, 4, 5, as you go on down. And y is going to represent how many dots there are, okay? Okay, so on the first stage, that's stage 1, there's 1 dot. That would mean the second stage, since n is 2, that's going to be like my x. How many dots are there?
2.
3, right? You count them, 1, 2, 3, and this is on your paper. I've just tried to quickly draw it here so the video would make sense if somebody was watching it. In stage 3, your x is 3 because you're in stage 3. How many dots are there now? 1, 2, 3, 4, 5, 6. And in stage 4, your x will be 4. How many dots do you have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, don't you? Okay, so now you could do this in your head at this point. You could say, okay, what they're giving me is the expression that the function is equal to. So how you would kind of read this is like when they say 3n, you would think y equal 3n, but didn't I call my n x's a minute ago? And the reason I did is because I can put x's in the calculator. Okay, I'm trying to think about how could I get this in the calculator to help me figure it out. So that answer choice A would mean, do these points fit y equal 3x? If I put 1 into y equal 3x, if x is 1, 3 times 1 is 3. My y should be 3. Was my y 3? No, so it's not that one. You could do this by hand and try, and let's just do that until we run into a problem where the math is taking us longer. If it were this second expression, this b, what you would do is you say, okay, that's y equal this expression, but instead of writing n's, I'm going to write x's. Let's try plugging in the point 1, 1. If x is 1, and I put a 1 in for every x, wouldn't I get 1 times 2 is 2? I don't have a 2 on my stage 1 as my y either, do I? That point was 1, 1, not 1, 2. So this isn't it either. Okay, so you're just trying to go, okay, can't be that one. Let's try C. I'm thinking C might be it. All right. You know what I'm going to do? Since I kind of look at C and I kind of go, okay, it's either one of the next two. It might be easier to check answer choice D out. You want to do D first?
Okay.
Maybe we do the easy ones first and then we leave the harder expressions as, for the last. If I look, I'm supposed to be getting the point 1, 1 on stage 1 here, and the equation's got to work for all these points. So if I look at D, I could say, okay, that's like the equation y equal n plus 2, except I'm calling my n's x's, and I meant to write x and I wrote n. Okay, so let me plug in x is 1. 1 plus 2. would be 1 plus 3, which is 4. Did I have the point 14? No, I had the point 11. So it must be C, and I'll show you how you could put this in your calculator in a minute, but let's just run one set of the numbers through. Now, we think that C is probably the answer because D didn't work either, did it? So let's try the one that might be the weirdest up here. Let's try the point 410 just because, 1, there's all kinds of weird things, all kinds of things that might work, but if we can get 410 to work in it, we're thinking that's a pretty good indication of if it's okay. So I also want to show you what you do if maybe you went out of order and you picked this one first. I'm trying to look at C to see if it's right. I'm pretty sure by process of elimination it is. But I'm going to write y equal this expression. Instead of n's, I'm going to call them x's, and the reason I'm going to do that is because in my calculator in a minute you'll see that it's easier to do it that way. I'm trying to see if point 410 works. So that's saying I'm going to plug in x is 4, and when I do, I want to get y is 10 out of this thing, and if it's the right one, it should work. 4 times, okay, plug in x is 4 again, 4 plus 1, all over 2. That would be 4 times 5, which is 20, right? And 20 divided by 2 is 10. That's exactly what I had here. So I'm pretty sure that's right, and if I were in a hurry, I probably would just say C's the answer and go on. But let's say I had a lot of time to think about this. What I could do is go to my calculator. So I'm going to pull up the calculator and put it up here. One of the things that's good about your graphing calculator is you can type functions into it. So let's say we put y, we'll go to the y equal, which we always have to do if we want to put an equation in the calculator, you have to go to the y equal to do it. And over here, what I'm going to type in, I'm going to check C out to see if all these points match up. But I can't really put n's in my calculator easily, but there's an X button on your calculator, and it's right here on this calculator. It's next to that green button that you see. And it's got like an X and a thing that looks like a T, and it's got like a circle with a line through it. That's an angle measure when you're working in trig. And it's got a little N here for sequences, but we're just going to put it in as an X just because, that's an easy way to do it. So I'm going to type in X, and I'm going to put the whole numerator of this fraction in parentheses, because when I have a fraction as a function, I put it in the calculator, I want to make sure the calculator knows this is all the numerator, and the rest of this is the denominator. So I'm going to put X, I'm going to type in X times X plus 1, and this is picking up on the video, but you can't see it on the video. And I'm going to end the top parentheses for the numerator of the fraction, and then I'm going to put divide, I can work with you, okay. And then I'm going to put divide by 2, because that's what this choice C, really on the bottom there's just a 2. I don't really have to put it in parentheses because there's only one thing. Now, on this graphing calculator, if I type it in here, I can hit graph and I can see a picture of the function, but that's not really going to help me here because it doesn't look anything like the dots I'm getting, does it? But I can also look at the table. That's what I care about, is the table of values. I can hit second, and that graph, right above graph on your calculator, it says table. And let's check all these points out now. I had 1, 1. Look on the calculator. I'll highlight the 1. Doesn't it say 1, 1? Can you see it up there? And it's kind of small, but hopefully you can see it. That point checked out. 2 should be 2, 3. Is that what I have here on the calculator right now when I type that function in? Yep. 3, 6. Oh yeah, there it is, right? And then the last one we had was 4, 10. And sure enough, if we look at that table, that function is giving me those same points. So what you do is you take these drawings of these dots, or it could be all kinds of different things, and when they label things with stages, like this is what they're saying in stage 1, when n equal 1, that's stage 1, this up here, these are going to become your x values and your points, and then you count however many things that are going on in the picture. In this case it's dots, it might be something else, and those become your y values. And then you can turn these into functions that you put in the calculator by changing the n's to x's and then just putting y equal in front of it. And that way you can actually use your calculator to do this. I didn't have to go through and do this. I could have gone through my calculator and typed in each one of these functions and checked the table of values really quickly. but I kind of wanted you to see that, you could do it in your head, but you could also use your calculator to help you find the right one. This is the kind of thing we kind of